Okay, this is just a short video on how to create a Maxwell's diagram for a fairly simple frame. So we've got a frame here that's got a 10 kilonewton force acting down on it. I've worked out that the resultant, or the support for it are 3.33 kilonewtons and 6.67 kilonewtons. And from here we can create what's effectively just a force diagram, but known as a Maxwell's diagram. So we need to start from a known point, and I've used Bow's notation to label the truss or the frame. And so we'll go A to B to C, and we've got force AB we know is 3.33 kilonewtons. So I'm just choosing a scale of 33.3 millimeters is equal to 3.33 kilonewtons. Whatever would fit on the page will do. If you're doing it by hand on paper, it needs to be bigger, or as big as possible. In CAD it doesn't really matter because CAD will be accurate. So right, so if working our way around this set of forces, this set of three, our next force is BC, and I'll label this because just so that we know where we are. And if I was doing it by hand, I'd put an arrow on this end because this force is acting upwards. It's a bit much mucking around to do it on CAD, so we'll just label it, and that way we should be able to remember where we are. So that's A. We'll just use a small a, and we'll call that B. Alright, so this force is acting in the horizontal plane, but we don't really know which way it's going at this point. So we can take a guess, or we can just draw the line straight through and then figure it out. But this force here is going to be our next one. So if this is sloping down this way or up this way, so there's a good chance that, well, they must intersect. So we can take a punt on that and say that so if this one here is sloping in this direction, this force must be in this orientation, I think. Anyway, we'll draw it in and see how we go. So we'll go back to sketch a line, and draw a horizontal line across this way, and then from point A, because we've got CA, so we need to draw another line up, and it's going to intersect. If you're doing it on paper, you just use light lines, and then you can line it in so that it makes sense to you when you're finished. It's not so important doing it on CAD because we can easily fix things up. So I'll just get our sketch, and I'll just make that line there needs to be parallel with that one. I could do it another way, but the easiest way is just to make it parallel so it looks like it is. Let's just see. No, it's not showing, so just hold the Control key down. Parallel. Okay, it is parallel. Okay, so they just have to be in the same angle. So now if we know that AB is 3.33 kilonewtons, we can dimension these two lines to find out our forces, just like we would in a normal force diagram. However, and we'll do that in the end, but for now we'll just leave that as it is, and I'll just label that one C. So where are we? Annotations. So we know where that is. Right, so now moving to our next force, our next corner of the truss or frame. So we've got BD. So BD will be vertical, and it will start from B. So it's another force heading upwards. So I'm going to get my sketch tool going again. I can draw a vertical line, and that represents this other support reaction, and it's 6.67 kilonewtons. So I'll dimension that one to the same scale. So we'll go 66.7, isn't it? Okay, so now that represents this reaction, this left reaction force, and then from there we know that, so we can now find force DC, which is going to come down at this angle. So if we create a line, it's going to connect to C. So, and I think we'll find that is parallel to that one. I hope so anyway. So we'll just get out of there for a minute, and it should tell me that, yeah, it's overdefined. So yes, it agrees with me, but I don't need to do that because it's already done. So we've now got a good chunk of our diagram done, and that's all the forces that relate to this this frame. So I'll dimension. I'll put a note on here just to. Going to do it for me now. Annotation note. Right, so we'll call that one D. And the last force that we don't actually have at the moment, we can't really draw it in, or we could, it's over the top, is D to A, which is this force, this 10 kilonewton force. But remarkably, if we mention this, it's going to tell me this is overcooked as well, but then never mind. Let me do it. Okay. Anyway, so that's our 10 kilonewton force, and in this case, it's acting downwards. So that's the Maxwell's diagram created, and if we dimension the other legs of the frame of the diagram, we can find out what those forces are. Okay, so that is the Maxwell's diagram for that truss. It's just a force diagram. There's nothing special about it, but it's just taking all the 3 force systems that are present here and putting them onto one diagram. So hopefully that's kind of useful. And there is a way, if we look at, we're going from, I just moved, these didn't move with it, did they? Got a bit messed up there. And if you look at D to A, that's a compressive force because it's heading downwards. So, and in the Maxwell's diagram, it's heading downwards. If we look at AC, so AC, that's going from A to C in that direction. So therefore, we could put an arrow at either end to indicate that that is also in compression. It's fairly obvious in this case that if you look at this diagram, you can tell without any analysis that if this force is pressing downwards, then they must be in compression because they're pushing upwards, or components of them, to support the downward force. And if those two are pushing down and outwards, well then this must be in tension. However, if we go to from C to B, so C to B, that's a force that's acting in this direction, and if we go the opposite way, anyway, that you can do it from the sense here of that the relationship is here. So depending on which direction we go to, that's probably a bit confusing, and let's not worry about that, because for this truss it's very obvious. Anyway, starting point, have a look at this and see whether that makes any sense, and we can possibly discuss it over the phone if necessary. Cheers.